Hello everyone, in this video we are going to continue exploring factoring out expressions, but this is going to be a little harder than usual. This assignment is kind of focused on the special cases about factoring expressions out. So on Study Island it's going to be more detailed. That's tomorrow's assignment. So for Thursday and Friday, you need to complete all these IXL assignments to get the highest grade possible, because these are going to be kind of your foundations. So the special cases formulas are going to be on Study Island notes and on tomorrow's video. Make sure to watch those videos out. Okay, let's get started. So before this one, I want to show you another example because this is a little harder than other types. So let's just start with this one. So one of the special cases is called difference of two squares. The general formula for that one is when you have an expression in the form of a squared minus b squared. So that a and b could be anything. You can expand it this way. A plus b times a minus b. This is called the difference of two squares. On the state test, this formula is going to be given. So what I don't mind is during the quiz or during these assignments, you can use the formulas that you can find online. Like you can, but for that you need to identify what kind of thing you are dealing with in the question. So in here, if you can figure out that this is the difference of two squares, you can just look up the formula and then try to kind of plug it in and apply it to your situation. So, but how do you tell if it is difference of two squares? If you just think about what I'm saying, difference means subtraction. Okay, so that's what I have in here. I have a difference and it's two squares. What does that mean? Like 4, 1, 9, 25. I'm not sure if you realize the pattern. Let me just put them all in order. 1, 4, 9, 16, 25, 36, 49, 64, and so on, 81 and 100. These are the most common ones. So if you don't realize what those numbers are, they're called perfect squares. It's because the first number is 1 times 1, which is 1. The second number is 2 times 2. The third number is 3 times 3. The fourth one is, and so on. Okay? So that's why those numbers are called perfect squares. Or these are also perfect squares. X squared, x to the 6th, x to the 8th, y squared, y 10th, y 20, m 120. What do you see when you look at those numbers? They are all even numbers. If you are dealing with variables with the power of an even number, then that means that's also a perfect square. If you can divide that power by 2 for variables. So let's check this one out. We have 4. That's a perfect square because it is 2 times 2. Y squared, I can divide that 2 by 2 because it's an even number. So I'm good for the first term. 4y squared is a perfect square. I can obtain that 4y squared by multiplying another term by itself twice. Look at the second term, which is 1, and that's a perfect square because it's 1 times 1. So if you can get that number by multiplying another number by itself, then that's a perfect square. So let's get back to what I said about this one. It was difference because of the subtraction of two squares. The first one is a square, which is 4y squared. That's a square, or perfect square. Keep using that term. And then the second term is a square as well. The difference of two squares. So now I can apply the formula. So the formula wants me to figure out what I need to multiply by itself in order to get a squared and in order to get b squared. Those numbers are a and b, or those terms are a and b, and all I do is add them, subtract them, and then multiply. Add them here subtract, and then multiply them together. Now, let's focus on the first one then. The first term, or the first square that I have, is 4y squared. What do I need to multiply by itself in order to get this term? It is 2y times 2y. Basically, you divide the exponent by 2, and then you get this y to the first power, and then 4 square root. I'll say square root. You learned about it, but probably you're not going to remember how to apply, how to do square root. So you got to come up with the number that gives you the original number when you multiply it by itself. And look at that one, that's my second term right here. So with that one, how do you get that one? By multiplying what two numbers by itself? It's 1 times 1. So the numbers, my A and B in this case, that's my A, this is my B. Add, subtract, multiply, remember? So right here, 4y squared minus 1 or minus 1 squared, there's no difference, right? I just wanted to make it look like this right here. But the problem with this, by the way, the answer is going to be 2y plus 1, 2y minus 1. But let me show you another way. You might like this better, you might like that method better. It's up to you, whichever you want to use, but I want to show you another method as well. So I need to make this 4y squared look like the whole thing is squared, because in here the only thing that is squared is that y. 4 is not squared. I don't see any square on top of that 4. But if I write it this way, let's check this one out. If I write it this way, instead of 4y squared, how about writing it this way? Now I don't have any 4 in there, but I have 2 squared. It's kind of like distribution property. It is 2 squared y squared. It's the same thing still, but now it looks like this right here. Bring down the minus. It was minus 1, but I can, as I said in here, I can write it as 1 squared. Now it's like a squared minus b squared. It looks exactly the way I wanted it to be. In that case, all I do is add the bases, subtract the bases, and multiply them together. Add them together. The first base is 2y, the second one is 1, and then subtract them and multiply them. It needs to look like exactly this way. You can put the second term, you can put this one as the first factor, you can put this one as the second one. It doesn't matter. You can just switch them, swap them. So that's the example. That's the first special case, the difference of 2 squares. And it has this formula. You might want to keep it handy. Write it on a paper. Keep it on the side when you go solve these questions. And keep those formulas close to you when you are doing your quiz as well. Okay, let's factor this one out. This is called, it has many names, but one of the most common name being used is trial and error. But I'm not going to kind of try, I'm going to kind of do that. Okay, so if you look at the step-by-step solutions to these questions, I don't think it'll make sense. If you spend enough time, it'll make sense. But as a teacher, it looks complicated to me. So I'll introduce you with my method, okay? So I'm not gonna show you the actual method that you will see in the solutions of IXL questions and in the solutions of study island questions, because it requires you to add and subtract terms and then kind of modify the given expression. That's too much. You will think that what I'm going to do is too much, but please, when you get a similar question, check the solution out and then compare my solution versus that one. You will see what I mean. So right here, there is a reason that the method is called trial and error, because that's really what you're going to do. You're going to try and find the right numbers and terms. So 25t squared minus 40t plus 16. We do this when we have 3 terms. That's a requirement. If you don't have a 3 term, you cannot do this. So the first thing is break this first term down, break this last term down. What do I mean by that? Look at those numbers as they are squares. They need to be squares, okay? Or I will take that back. They may not be squares, but just break it down. Divide them, break them into smaller pieces. You need 2 factors from the first one, and then you need 2 numbers from that one. So logically, when you see 25, the first thing that comes to like almost everyone's mind is like 5 times 5, right? So let's just start with that. This is why the method is called trial and error, because you go by your gut, and then whatever it tells you to do, you just do it and then see if it works. As you go, kind of practice makes it perfect. You start to see the numbers that you're looking for. You kind of focus on the right numbers only instead of just plainly guessing them. And then t squared, how do you break it down? Like, the only way for that is t times t. So that's the first step. And then look at that 16. What's the first 2 numbers that comes to your mind? Mine tells me that it is going to be 4 times 4. Again, it could be 8 times 2. It could be 1 times 16. And you'll have different answers when you just switch them around. Like, instead of 2 times 8, if you put 8 and 2, you're going to end up with a different answer. That's why this is called trial and error. And you kind of need to know how to play with the numbers. You kind of need to know what happens if you just multiply 3 times 7. And you need to be quick for you to solve these questions without spending a whole lot of time on it. Now, what I will do is I'll try to end up with this middle number by doing cross multiplication. Okay, that's the key. We are going to do cross multiply, and then we will try to end up with negative 40t. The sign matters. The variable matters. The number matters. It's not just one or 2 of those things. They all need to be the same. Now, this one here is positive 16, right? You don't want to just put 4 and 4. You need to be careful with the signs. So they need to be either both positive or both negative, because, okay, let me show you something wrong first, okay? Let me take this away. Let's just say I picked my numbers like this. What is negative 4 times positive 4? It's negative 16. But I need a positive 16, right? So that's why this is going to be wrong. They're either both positive or both negative. Got it? And then let's start with the positive ones, because that's like the first instinct. I know this is going to be wrong, but I want to start it with positive ones because I know you don't have that experience. You can tell whether it's going to be plus or minus. You haven't solved any questions about these ones, which is totally fine. Now, let's do our cross multiplication. What is 5t times positive 4? It's 20t, right? But it is positive 20t. And then multiply these two. 5 times positive 4, another positive 20t. When you combine these two, you get positive 40t. But that's not what I need. I need negative 40t. So how else can I get that number? What if I do this? When I multiply these numbers, it needs to give me 16. Okay, that's the first thing. Let's check that out. Negative 4 times negative 4, that gives me 16. Positive 16. I'm good. Now let's do the cross multiplication. 5 times negative 20 is negative. 5 times negative 4 is negative 20t. And then 5 times negative 4 is another negative 20. Keep that variable. Combine the like terms. Negative 20 minus 20 is negative 40. Keep the variable. Again, we are just adding or subtracting, then we keep the variable. That's a check mark. I ended up with the right thing. So that means finally I found all of my numbers. They're in the right spot. Everything looks fine, looks perfectly fine. Now the last step is pairing them up and then multiplying them. But not that way. When you write your final answer, this is how you pair them up. First line goes together, second line goes together. And when I say they go right next to each other, that's exactly what I mean. All you have to do is 5t put that 5t, and then minus 4, put it in a parentheses, and then write your second line, 5t minus 4. And this is multiplication. Even if there's nothing, you don't need to see that dot in there. That means multiplication, and this would be your final answer. You would do parentheses 5t minus 4, and then 5t minus 4. This is called trial and error method. Let's move on to another example. Another trial and error question. So I see that this is 7 times 7, 8 times 8. Those are perfect squares. So I'm going to try to divide it that way. Because if it's perfect square, probably they want me to set it up that way. Okay, 49, let's start with blank. 49m squared minus 112m plus 64. So my instinct tells me that this is 7m times 7m. 7 times 7 is 49, m times m is m squared. And this one, I'm going to try to do it this way, 8 times 8. So when I multiply these two, I need a positive 64, so I can set it up this way. But in that case, when I do cross multiplication, this is going to give me a positive number. That's going to give me a positive number when I multiply them, because everything is positive. I'm not going to end up with a negative number. So that tells me that my numbers are going to be negatives, not positives. But if you don't see that, you can just do whatever the name of the method tells you to do. Try, see your error, get back, and fix it. So let's do it this way now. I want to first test the product of these two numbers and make sure that it gives me positive 64, which works perfectly fine. Now let's do the cross multiplication. 7 times 7m times negative 8. That's negative 56m. You don't need to do it step by step the way I am doing it. And then 7m times negative 8 is negative 56m. And when I combine these two, I want it to be equal to negative 112. So when I combine them together, negative 56 plus negative 56 is negative 112. Keep that variable the same. So the numbers and the terms are in their right spots. What I need to do as the last step is combine the first row and the second row. For these numbers, it doesn't matter whether you do cross multiplication or the first line, second line thing, but there are going to be questions where it matters. So, and this method is always going to work. So when you write your final answer, make sure to pair the first terms up and then the second ones. 7m minus 8 is the first factor. 7m minus 8 is the second factor. Do you see that they are exactly the same? I think this was the case with the other example. If that was the case, here is what you need to do. Because I think it was 5m minus, what was the number? I don't remember the number from the previous question, but I think both of the factors were exactly the same, right? My bad. I need to get rid of this. So if that was the case, I did it wrong. I did it right. I didn't completely finish the question. So if this is what you're ending up with, it's like doing 6 times 6. What is 6 times 6? You can put 36, but you can also put 6 squared, right? Instead of 6 times 6. Or what about x times x? We don't leave it as it is. We put x squared. So if you're multiplying the same term by itself, you just increase the exponent. You write it this way, 7m minus 8 squared. My bad. I think this was the case with the other question as well. If that was the case, make sure you write your final answer accordingly. This is also called perfect square trinomial. Okay? This is also called perfect square trinomial. I don't want to show you the formula for that one. You're going to see the formula. I can show it. Doesn't matter. Okay, let me just put that formula. You're going to have this formula on Study Island as well. This one is minus, so I'm going to use this formula. a squared minus 2ab plus b squared. And there's this one here, a plus b squared equals a squared plus 2ab plus b squared. So on the study island video, I may show you the way that you can use these two formulas to solve these questions, but then again, does it worth to memorize two more formulas if you can do it using trial and error method? Because there are going to be questions that the only thing that you can do is this method, trial and error. And then there are also questions like this one here and the previous question where you can utilize these two formulas, but that requires you to memorize two more formulas. Yeah, I'll see that on Study Island video. I may or may not tell you how to use those formulas, but memorizing formulas, I'm not a fan of that. So let's move on to the next example. Let me see if this would work for that, because if it does, I will use the formula so that you are familiar with that method as well. 5,566. Okay, yes, this is a perfect square trinomial. So look at that 25y squared. How do you break it down? 5y and 5y, right? It's 5y squared. This right here is 5y squared. That one here is 6 squared, correct? If the middle term is, multiply that, my bad, I wrote that one wrong. It should have been this way, not like that. Oops. So that pattern requires you to multiply these a and b, 5y times 6, and when you multiply this by 2, if you end up with the middle term, that means you're dealing with a perfect square trinomial. So 2 times 5 is 10, times 6 is 60. Keep the y the same. So yes, this is a perfect square trinomial because I broke this one down and that one down. I multiplied the basis, 5y times 6 times 2. If you remember, that was the middle term in the formula. I'm going to put it up again. Then that means you're dealing with perfect square trinomial. Here is the formula. Since they're all positive, so it was like this. A plus b squared equals a squared plus 2 times a times b plus b squared. So this right here is 5y squared. That one here is 6 squared. And then the middle term is 2 times 5y times 6, because when you do this, it gives you whatever that is, 60y. In that case, all you have to do is add them and square. Add what? Add your bases, 5y and 6, add them together, and then square the whole thing. You can either use the trial and error method, that works all the time, or for some of the questions you use that method, for some you use this method. If it's a perfect square trinomial, which means that should be a perfect square, this should be a perfect square, and that middle term should be 2 times the product of these two. So that's totally up to you. This was a different method with the formulas. So I'm going to leave you with either one of the methods, whichever works fine for you. Probably you're going to be like, neither one of them works with me, so yeah. Okay, let's check this one out. What does this look like? This is going to be the last question that I want to do. I really hope that you see that there's only 2 terms, and the only thing that we learn about having 2 terms is difference of 2 squares. There's only 2 terms. I'm going to make them look like squares. Let me see. First thing, 121. Yes, I see how to do this. The first thing that you want to do is you want to look for the greatest common factor. That's 242. The other number is 162. And I can divide both of these by 2. I can also divide them by different numbers, but let me explain why I want to divide them by 2. So if I divide them by 2, the first number would become 121, and I know this is 11 squared. again, I'm looking for a difference of two squares. And then this right here is 81, and I know that number is 9 squared. But in order for me to end up with these two numbers is factoring out the 2, right? So when I factor the 2 out of 242, that becomes 121. I'll keep the m squared the same. And then minus 81. And as I did over here, 121 is 11 squared, and then it's times m squared minus 9 squared. I'm doing it step by step. I wouldn't solve this question like that if I'm doing it on my own. So 11 squared times m squared is the same as 11m, and then square the whole thing instead of squaring them one at a time. Minus 9 squared. And then all of these are inside parentheses. Now that looks like a difference of 2 squares to me. I'm talking about what I have inside the parentheses. So my final answer is going to have the 2 that is outside of everything, and then the parentheses, the brackets, have difference of 2 squares, right, inside them. And then that one, you can find the answer by adding and subtracting and multiplying. Add the bases. The first base is 11m. Add them together. The second base is 9. And then multiply them together. 11m. My bad. Subtract and then multiply them together. So this would be my final answer. 2 times 11m plus 9, and then times 11m minus 9. But that's totally up to you. I don't think you're gonna be struggling at the 90s level on this question because this assignment is gonna take a while. So let me know if you have a question. Thanks for watching, and I will see you in another video after trying to stop this one here because it usually takes me like 5 seconds. So thanks again for watching, guys. Yeah, I'm still trying.